So, today we're diving into something called HACK3D. It's basically part cybersecurity challenge, part high-tech scavenger hunt, and it gives us this fascinating window into how digital problems can cause some very real, very physical damage.
I mean, just think about that for a second. It sounds like something straight out of a sci-fi movie, right? But this is the exact question Hack3 is trying to answer. Imagine an almost invisible flaw slipped into a digital blueprint for, say, a critical airplane part. A flaw you never see until the part is under stress, and then it's too late. This is the new front line of industrial security.
Okay, so to really get a grip on this threat, we've got to understand how things are actually made these days. Because modern manufacturing, it's almost entirely a digital process, long before any physical materials are even touched.
And this right here, this shows you that whole journey. It all starts with a 3D CAD model. Think of it as a digital blueprint. That blueprint then gets sliced up into thousands of super thin layers. And those layers are translated into something called G-code, which is basically a set of step-by-step instructions that tells a 3D printer exactly how to move, what temperature to be, layer by tiny layer until you have a final physical object. Right, and here's the scary part. Every single one of those digital steps is a potential point of attack. A hacker could mess with the original blueprint, they could change the printing instructions, or they could even just steal the design to make their own counterfeit parts. The whole digital assembly line is vulnerable. So, how do you possibly prepare for a threat like that? Well, you run a fire drill, and that is exactly what HACK3D is. It's this high-stakes competition put together by New York University to test the security of digital manufacturing by, actively trying to break it. The whole thing is set up like a classic cat-and-mouse game. On one side, you've got the blue team. Those are the NYU organizers, the defenders. They design parts with all these hidden security tricks baked in. And on the other side, you've got the red teams, the attackers. These are students and experts from all over, and their one and only job is to find the weaknesses and break the defenses. But, this is way more than just a game. The whole point of HACK3D is to seriously stress test new security ideas. The attacks that the red teams come up with, which are sometimes completely out of left field, give the defenders priceless data to build much stronger, much more secure systems. All right, let's get into the good stuff. We're going to look at our first case file to see how this all plays out in the real world. In this challenge, the red teams had a pretty tough job. They had to spot an intentional flaw hidden inside a booby-trapped blueprint. So the mission for the attackers seemed pretty straightforward. They got the digital files for two different parts and were told, go ahead, 3D print these perfectly. Easy, right? Well, not quite. The files were designed to fail from the start. Check out these designs. The blue team, the defenders, they got clever. They hid these little security tripwires inside the files that would create either tiny nicks on the surface or worse, hidden weaknesses inside the part unless it was printed in one very specific orientation. Any other way, and you just get a useless piece of plastic. Now, finding that one perfect orientation, it's basically impossible. With 360 degrees of rotation on 3 different axes, we're talking about nearly 47 million possible combinations. There is no way you could just guess your way through that. And this is what happens when you get it wrong. On the left, you can see how the path the printer takes is broken up, which creates a really weak part. On the right, there are hidden empty spaces inside what should be a solid block. I mean, these are precisely the kinds of sneaky, dangerous flaws a real-world saboteur would want to introduce. So how in the world did the red teams pull it off? It wasn't some crazy, complex code. It was pure, hands-on experience. The seasoned 3D printing pros on the teams knew that to get a really good print, you need 2 things: a nice, continuous path for the printer head on each layer, and a big, solid base so it sticks to the platform. By just looking for the orientations that met those physical rules, they took that massive 47 million possibility problem and shrink it down to just a few likely candidates. It's a brilliant reminder that sometimes real-world know-how can totally outsmart a purely digital defense. Okay, for a second case file, we're shifting gears a little bit. This one is less about sabotage and more about straight-up intellectual property theft. The challenge here was to rebuild a complete design from just one tiny broken piece. So imagine this. The red teams get a corrupted G-code file. All it can print is the base of a chess piece. Their job was to figure out what piece it was, a pawn, a bishop, a queen, and then rebuild the rest of the file to print the whole thing. Now, some teams went the hard route.
using image processing and careful measurements to reverse engineer the missing part. But the blue team, the defenders, they actually hid this amazing little shortcut right in plain sight for anyone clever enough to find it.
Deep inside that file for the base, you'd find this, what just looks like a random cloud of tiny spheres. To most people, it would look like junk data, just a meaningless jumble. But it was anything but random.
Because here's the magic trick. If you rotate that cloud of spheres to just the right angle, bam, it snaps into focus as a perfect, scannable QR code. What an incredible aha moment, right? It's a fantastic example of hiding a message inside another file.
And what happens when you scan that code? It takes you straight to a link on a cloud server where the defenders had stored the file for the missing top half of the chess piece. The puzzle was the key, and the QR code was the lock. Puzzle solved.
So after all this back and forth, all these clever attacks, and even cleverer defenses, what's the big takeaway? What did the hackers actually teach us? Okay, it really boils down to a few key lessons. First, digital files leak way more information than we think, like that hidden QR code. Second, having a team with a mix of skills, computer science, mechanical engineering, is an absolute superpower. Third, you can never, ever underestimate how creative an attacker will be. They'll always find a way you didn't think of. And finally, like we saw in that first challenge, sometimes good old-fashioned practical experience can beat the most complex digital security. And look, this is why all of this is so important. What we're learning from Hack3 isn't just for fun. It's being used to make the manufacturing process more secure for critical industries. We're talking aerospace, medicine, defense, places where a single bad part could be absolutely catastrophic. At the end of the day, what Hack3D really hammers home is that our physical and digital worlds are completely intertwined now, and our ideas about security have to catch up. It really leaves you with one big question. In this new reality, how do we make sure we're always staying one step ahead?